Hello and welcome. My name is Francesco Vigano. I will be the moderator of this webinar today, and together with me is Dick Ottosson, Head of Marketing and Automation Sales Support in System 3R in Sweden. Today we will talk about the AMR concept by System 3R. AMR is our new product, and we will also have a connection with Hans Mustonen, our product manager of the AMR product in our factory in Sweden. Today we intend to give you hints and insights about our AMR product and look together about how it works. AMR is the autonomous mobile robot, and it is the new product by System 3R in our portfolio. Together with the Workshop Manager 5 software suite, it will be the basic component for the new concept that we propose to our customers to move towards the lights out factory. So let's begin.
Thank you, Francesco. To begin with, I would like to start with the existing product portfolio that we have at System 3R. Just to remind, because these are important to tell also when using it in combination with AMR. We have the smallest robot, that's the WorkPal 1, who can support one machine and up to 50 kilo transfer weight. And then we have the big brother to which is the WorkPartner 1 Plus, where you can have different combinations of the magazine, so you can actually have up to 12 different variants of that, combined in the light, heavy and the rotary magazine. And this supports one and up to two machines, and the transfer weight is 80 kilo.
80.
Then we have the transformer 3-axis in three different models, the 100, 150 and 200 kilo. It can be stationary or it can be put on a rail system up to 25 meters and supporting up to 12 machines. And then we have we became in 2015 a Fanuc integrator, so that means we have the transformer 6-axis, as we call it, in our portfolio, and we have 5 models to play with, and that's the 70 kilo, 165, 210, 360 and 700 kilo. And this can of course be a stationary or a linear rail version as well, supporting up to 20 machines and a 40-meter rail. And then we have the newcomer in the family, of course. That's the AMR, and we are now becoming also integrator for the AMR products. It's a Japanese product, and we have selected in the portfolio to start with the LD90, and 90 is the weight to carry on top of the AMR, and also the LD250. So this is important, and we are going with the AMR. We're going to serve the work partner up to the big robots, actually, because we are coming later on to handle more weight. But the intention is to serve the full portfolio from WorkPartner 1 Plus up to 700 kilo with an AMR solution. Not the WorkPal, because we cannot really enter and access into that robot.
Yeah, well, and typically the WorkPal is used with a single machine, so it's a very little and tiny entity, while the other robots are more open to a wider layout of cell and layout of workshop, where the AMR can be a good player.
Yeah, correct. So with that said, we can also say that the WorkPal and the WorkPartner 1 Plus, these are the standard solutions which are boxed in. And then we have the high-end automation side, where we have the transformer 3-axis and 6-axis. And here is also now the AMR solution coming in, because you could have a mix of different cells. You can have one or several AMRs, different types of AMR, and this becomes rather complex. So that's why we also have a special team at System 3R called CAP team. CAP is Complex Automation Projects. Our objective with this AMR portfolio is to have a flexible and agile transfer in between the cells that we are going to serve. And it can enable transfer not only to one cell but also in between the cells, so we can have a material flow with the AMR to transport. And this is what we call the lights out factory vision or concept that we are proposing. So we can transport not only the pallet itself, which can be the tooling systems that we provide. It can also be electrodes, fastened to a pallet. In the long run, we're also going to aim to transport cutting tools and also raw material for parts handling cells. So that is in the development plan as well, and the objective. And this is to really have an intervention not only daytime but also nighttime and also over the weekends. And that's why we call it the lights out factory. So you can really produce 24/7 for 24 hours or 48 or 72 hours, depending on the material buffer you have.
On the magazine side that you set in this kind of layout, then all is done and all is in the hands of our automation systems.
Correct. Okay, let's have a look on the capabilities of the AMR itself. Well, it supports what we call multi-technology cells. That can be a milling cell or a die sinking cell or YVDM, or it can be a mixed cell where you use both milling and die sinking inside of it. It will manage the material to move it in between the cells, but also in between buffers that you have. And then it ensures a flexible and agile production where you can mix a low and high volume and different products in it. This we are already handling today with the technology cells, but here you can really get the flow in between. And of course, we are not just saying that this solution has to be fully automated. We also need to have support if something needs to be on service, etc. So you can have a human intervention and bring the material to the cell and put it into the cell as well. That's important. So let's have a look and see, because there is AMR is a wording autonomous mobile robot, but on the market there has been what we call an AGV, an automated guided vehicle in that sense. And what is the difference here? Because there's a lot of mix-up in between these.
Better to clarify once more.
So the AMR itself, it doesn't require any kind of magnetic you call it strips in the floor, etc. It's no preparation on the floor at all. And it's also using a scanner, front scanner. It has actually a sensor on when moving in reverse as well, but it looks in 24 degrees angle and scan the objects in front of it, and can avoid objects in that sense. Which an AGV cannot do. If there is a stop in front of it, it will stay and wait. But
of course, so you have an obstacle and then the AGV is moving on his path. It cannot go out of this path, and so it stops in front of it. While the AMR is able to find alternative routes.
It recalculates the route and go around. We can also, with AMR, you can have a multiple of them in the factory. You can actually have up to 100 units.
Oh, so many.
I assume that's really a logistics center in that sense, but multiple of them, and you can have also different tasks for the different AMRs, of course. But this is also a kind of, smart system and safe and intelligent transport system in your factory, and it has to work with human beings as well. During daytime, when you have people walking there, it has to be very safe
this is much important. We have a robot and human interactions. Robot beings, human beings, all together in the same environment, autonomous during the night, for instance, but collaborating during the day and not hitting each other.
Yeah. Okay, let's speak a little bit about the multi-technology cells in that sense. In all factories, you have probably these type of production cells. We call it technology cells in this sense. It can be cells where you do a certain thing, meaning you can mill electrodes in one cell, and you can mill steel pieces to be used in a mold. You can have wire EDM cells and washing, cleaning, etc. And of course, you can have technology cells where you have several technologies in a cell, like a linear cell, moving milled pieces directly to a die sinking.
For instance, yes.
But the AMR solution is going to be used to feed these technology cells and also bring it from one operation to another operation, meaning from milling perhaps, and then go over to die sinking. So the logistics in between the cells is what the AMR is focusing on.
Well, so let me better understand. We are talking about technology cells, so we try to keep separate the technologies, or at least to create some islands. But then we want to connect these islands, and here the AMR plays its role. It's like a second layer of automation over this primary layer with the robots in the technology cell. There is a second layer, which is the AMR. Did I understand well?
Yeah, it's a good way of expressing the need for it. Yeah, definitely. So let's try to visualize this a little bit. If you have a certain material and data flow where you prepare the orders, the material, etc., and then you bring it to the production, and the output is finished products. Hopefully, in the end, you have finished products. And that means you can use the technology cells for producing the different operations.
Okay.
But if it's going from one operation to another and there is no link in between, that's where we put in the AMR.
Oh, yeah.
So you can use it for the transport to bring material to the cell, but also bring it from one cell to another. And this is what the AMR is doing.
Okay.
And if it's enough with one or two, depends on the cycle time and also the buffer you have in the system, which is important. And the point is here is now that now you can run it unmanned, and this is the lights out vision or the concept that we are given to the market now and proposing to the market. So that's the lights out factory.
Real. So in the end, we have the necessary and needed human intervention in the beginning, bringing the materials, bringing the data that are the program files to execute in the machines and in the cells. And then we expect to have the finished products in the end, again, handled by humans. But all that is in the middle can be done by automation autonomously, so that you can turn the lights off.
Yeah. So let's look at the benefits when having this second layer of automation and what can be brought with the AMR. Well, I can click on all of these.
Let's show them all.
Yeah. So we can keep the production running 24/7. That's important, and we can solve the material management to the cells and in between the cells. You have the ability to scale up your production if there are bigger volumes. Just add another AMR or add more to the material buffer in that sense, or add more technology cells or machines in that sense. You can mix the products. We handle one batch, single batch order, or it could be multiple pieces. It doesn't matter. And we can also utilize the existing floor space in a factory in a better way. Instead of creating big cells that takes a lot of space, you can keep your existing production cells and then use the AMR. As long as there is enough space for the AMR to navigate and run.
That is a clever idea, because you use the same space, the same corridors and aisles that are normally used by humans.
Yeah.
You can use them also for these AMRs that in the end are quite compact.
Yeah, definitely. That's the whole point with it. And then, of course, if you have a structured way to do everything, hopefully you minimize the errors in the production. And of course, this type of solution has to work alongside with human beings, because you're not just producing during the lights out area, you use it during the day as well.
Correct.
Yeah. And it has to be safe, of course. So let's look at some other benefits in that sense as well. So the concept we have is that we on top of the AMR we have what we call a tray, and that's the carrier of what we would like to transport. And in our case, as we are having palletized automation, we transport pallets. On top of that could be a vise, and then they have the workpiece, or a workpiece directly mounted. And it could also be electrodes on a smaller pallet, macro for example. And then of course later on it will be cutting tools and raw material. We can handle up to 250 kilo with the LD250. And then it's a pure mechanical solution on top of a standard AMR. So it's really easy to equip the AMR with a carrier depending on the tooling system. And then we are planning to have a cart solution on the LD250, meaning that it's like a cart or wagon that actually the AMR will pull. And instead of having weight on top, we pull the cart, and then it can be up to 450 kilo. That means in the end we have a solution from half a kilo up to 450 kilo with the same type of AMR, the LD250. Nice. So that's also ongoing. So what do you need? What are the components, so to say, except for the AMR and the tray? Well, we have selected the LD90 and the 250. We need a tray lifter for what we are carrying. And of course you need a tray to put the pallets on and the electrodes. And then you need some software as well. We need a fleet manager software, which is actually keeping control of where the AMR are in the factory. And then you have a system on top of that, communicating probably with the customer's ERP system, material handling. And for us, it's the Workshop Manager 5, who will be the brain that connects everything. So we know what is going to be transported on the tray, and to which technology cell, we're going to move it. Just shortly here, we see the components again with the LD90 and 250, the tray and the lifters.
Yeah, we see all the elements, and you can also freeze the video and look into the single lines.
Definitely.
Some of them are already available now, so ready to discuss and ready to implement in your factory. Some others are coming in the next months as an evolution, but they are already there is already the predisposition for the system thanks to this concept of having the AMR itself and building on top with the trays and all the other equipment. So this is a great degree of freedom, so that we can put almost whatever we want on top of this on this AMR.
Sure. Of course, you need some other components as well. When entering a cell, you need the fencing, light barriers, photocells, and because it has to be safe, and no human being should be there, of course. Okay, quickly on some specific data for the LD250, handling weight 250 kilo, of course. Important things here is the safety scanning laser that you have in the front. It's actually sweeping at 240 degrees.
240.
Yeah, and so that will find obstacles in the way. Then you have also a low front laser to sweep the floor, because there could be stand-ups on the floor.
Small things
small
there.
things, exactly.
Nice.
We have a rear sonar, because when the AMR is moving backwards, it has to check as well so it doesn't collide with a person, a human being, or something else.
Any object.
Yeah. On the sides you have some light disc just to tell which, communicate to the surroundings on what's doing, and it's also blinking so you can see.
And by the way, they also look very nice.
Yeah. If it's dark in the factory, you should
See that the AMR is there.
Yeah. Same thing with the LD90. It's 90 kilo, and otherwise it's the same safety things here with the scanner and the rear sonar.
Correct.
Here we can see some produced trays, which is on top of the AMR. On the left side, we can see the tray with 12 position of the macro tooling system, normally used for electrodes, but also could be small workpieces. On the right, we see the tray for a Dynafix, which is 280 by 280 pallet, and on top of that you have the workpiece. Of course, we designed the tray depending on the tooling system which is sold to the customer, and that could be Magnum, or it could be GPS 120, 240. Could of course even be our competitor tooling system, because we have a lot of customers on the market using a specific tooling system, but our robot.
Yeah, beautiful. So maximum flexibility, also adapting to toolings produced by other players in the market. We can adapt, again, thanks to the great flexibility given by the tray that is put on top of the handling system of the AMR.
Okay, and here we focus a little bit about how it looks when you're entering a technology cell. We have this fencing, and we have some photo cells and light barriers and home sensor to make sure that the AMR positions correctly, because you should actually say that an AMR is not that accurate. It actually can position within minus 8 millimeters. So the solution we have made with the tray and the lifter, we ensure that we have a good, accurate position for the robot in the cell to lift the material off the tray. And here is the positioning, I would say, is within 0.2, 0.3 millimeter. So it's really accurate.
That is beautiful, because you see, and you saw in the previous slides, that we have this conical connection between the tray and the AMR itself. But then this same system with the conical coupling is used also with the lifter. And the lifter is permanently fixed at the cell. The relative position between the robot and the lifter is known. So then the lifter is lifting the tray and putting it in the correct position for the robot, even if the AMR is getting very close, but not exactly in the precise position. So we can stay below 1 millimeter precision to the robot side. So for the robot, it's perfect.
Yeah, definitely. Just to describe this a little bit more, we don't have Hans Mustern here in the studio, but we would like to connect to him live here, so he can present the components and the security and safety in the cell. So Hans, can you hear us? We would like to leave over to you so you can explain a little bit more. Over to Hans.
Yes, thank you. Now we're going to show you a short live demonstration of our hardware and safety concept. Our concept can be used to all our robot types. In the concept we have a load cage, we have a fencing for the physical protection, we have an automatic door on the robot side, and we have the light barriers for the safety to the load cage. We have a muting sensors for allowing the AMR to enter. and we have a home sensor that verifies the final position of the AMR. And we also have this control box, that everything is connected to this, and this controls all of the functions and features of the safety and the lift station. If the lift stations need to be handled manually, we can easily set it to manual mode, and then we can lift and unlift the lifting station. If you, for example, the AMR is on service or something. And here we can see the AMR coming, driving to its goal position outside the load cage. When it reaches its goal position, it will start communicating with the system controller and the request to enter the cell. And the system controller is checking that all of the sensors and the safety features are okay in the load cage, and then the AMR is allowed to enter. Now we will pass in the first muting sensor. We're starting to mute this light barrier. We will mute this about approximately 900 millimeters. This can be adjusted. It's depending on the workpiece height. And when the AMR is in its final position, the home sensor is activated. And now it is possible for the lifting station to be operated, to load and unload the tray. At this stage, the automatic door is open and the robot can pick up the workpiece. And now, back to you in the studio.
Okay, thanks Hans. That was a good presentation of the AMR, and we could see a little bit more and understand how it works. So let's continue here now, and we go over to how it could look on the cell part of the AMR. Here we have an example with Work Partner 1 Plus. To the right we can see a Work Partner 1 Plus with one machine. That means we can use the other side where we normally could have a second machine, and we just put an automatic door there. We place the lifter on the floor and we do the fencing and the security part. Correct. So that means we can have access to the tray which comes with the AMR. And on the left side we can see here we have the Work Partner 1 Plus with two machines. That means we have no open side to have the robot arm. But now it's clever, we have actually redesigned the light magazine, so we will put an automatic door there, and the robot arm can go in and out and pick from the tray. So that is supported now on the VPT1 Plus that will be launched during 2024.
Beautiful, because you know that the Work Partner 1 Plus is one of our bestseller robots. Yeah. It's made for feeding two machines, so we didn't want to miss this opportunity. Having also the access for the AMR with a specific door on the light magazine. Yeah. Very nice.
Then if we move over to the transformer 3-axis, again it's a similar items or components needed here, the lifter, but of course to block to have a secure cell, we need to have an automatic door, because we are coming with robot arm out to the lifter. So this is how it looks when we have the transformer 3-axis, and it looks the same actually when we have the the transformer 6-axis. And what's important here is also that in these technology cells that you have a small buffer. Well, with the pallets, as you normally have when you don't use an AMR, but it can be minimized to a lower end. You don't have to maximize it, but it's good to have the buffer, because if you don't have a buffer, the AMR will be really occupied to bring material to all the cells which are finished with the workpiece.
Yeah, one pallet by one pallet.
And that is not the purpose, because then you need multiple AMRs, etc. Then it's better to invest in a kind of right size buffer magazine, so you can run perhaps 5 to 10 jobs without having AMR supporting.
Real. So we minimize, let me repeat if I understood well, we minimize the internal buffer of the technology cells. We move this buffer to a more rational and logic position that can be the general magazine where the AMR is picking the parts and the components and the electrodes and bringing them to the cell. We still have, and we see that in the image on the representation of the cell, we see that a couple of magazines are there. But I saw many cells with as many magazines as the machines are. So in this way, we increase the added value for the space where we have the cell, becoming something full of machines, not of magazines, just to have pieces and parts resting there doing nothing. Okay, the parts are in another place, and the player in the middle is the AMR.
Yeah. With this AMR concept, we have kind of a new item or logic here to solve as well. And that is, if you have not only one tooling system, you have multiple tooling systems. And if we take the case, the macro and Dynafix, you have one tray for the macro and one for the Dynafix. And when the AMR is using the tray for macro, it has to put the Dynafix tray somewhere. And this is what we call a parking station. And vice versa, if the AMR wants to bring something on the tray for Dynafix, it has to leave the macro in the parking station. And of course, if you had 3 tooling system, you need to have 3 parking places for it. And it also depends a little bit the number of trays you have and the number of AMRs. But that's a new kind of item in our price list, what we call parking station. And then of course we have the preparation station. There could be different ways of bringing material into a factory. You can use a preparation station. In this case here, what we see here is a station where you have access to the Workshop Manager 5, meaning you can connect the pallet, which has a workpiece on or electrode on, and you have the ID chip. And then you create your job in Workshop Manager 5 and tell which NC program, where to run it, in which technology cell, and then you connect it. And then of course you can load the tray directly and bring it to the technology cell. Or you can also have a material buffer cell.
Oh, that one.
And I think that is more clever in that sense, because you want to create a situation where you are as unmanned as possible. You can use the daytime to feed cells or the buffer, and also to remove finished parts from the buffer cell during daytime. But over the evening and the night and the weekend, you should produce. So what could be mentioned about the material buffers cell is that here you prepare something and then you send it to a cell, so it's stored. Multiple pallets depending on the tooling systems. And this will be a buffer, so when there's an order to run, we need 10 electrodes, the AMR goes to the buffer cell, a robot loads on the tray 10 material pieces, and then it goes to the technology cell to be produced.
Okay, nice. That can be made in different shapes. It can be a buffer cell with another little robot inside, managing the flow inside the buffer cell, and then giving the parts and giving the electrodes to the AMR to bring to the technology cell where the machines are. So we have the buffer cell, which is just a big magazine, but with a high technological content. That is.
And the plans are also to we can produce and have set up a material buffer cell with our robot and magazine, but the plan is also to have a high storage magazine like a Cardex.
Okay.
And then of course you need a robot, so you can bring from the Cardex, you have to load the tray. So this will also be part of the solution.
With an ideal utilization of the floor, because we know that the floor is money in the end. The space is quite important and always a scarce resource. Using the height is a clever solution.
So you could say that you feed in material and you get finished part back in the same. Well, an AMR is running on battery. So we need to have a charging station for it. I mean, roughly the average time to run is 10 to 12 hours, depending on the load and the weight you have on top, of course. But there are smarter things. I mean, everything is handled from an automatic point of view. But you can set levels. So you say if the battery level go below 30%, you have to go in and charge. But you don't have to charge it up to 100%. You could say that charge up to 70, then you can go out and work again. And of course, if you know that you have a stressed scheme in some way, you can always change the battery. It's like this is really quick to change. So you can take a fully loaded battery and put it into the AMR, close it, and then you have 10, 12 hours again. And then you charge that battery, which you took out.
When the program of the day is very, very hard, you can also have this further opportunity. Nice. You mentioned that all is managed automatically, but up to now we spoke about hardware elements, hardware things. What about the software that is managing this? Is this all managed by our workshop manager, or is there maybe a mix with some software modules by Omron? I guess that's a positive collaboration in this.
Yeah, of course. I mean, there is a mix of software. You have to have what we call the software fleet manager, and that's from Omron. And this is mandatory to use with AMR. And it can handle up to 100 AMRs, I mentioned before, and can be different models, etc. So that's a must, and it's mandatory. It's coming. And if you look on the fleet manager, it has certain skills within it. And of course, you have something called traffic control. Means it doesn't collide with other AMRs if you have several working in the system. And it also has something called managed motion. Means that if you have several AMRs and they want to go to the same technologies cell, they have to queue up in a nice way, so it will not create a mess. And that is managed by this. Then I mentioned the charge management, the battery level. It knows when to go in and charge and go out back and work again. Then we also have the ability to select depending on the work that has to be done. If you have an LD90 and an LD250 in the same factory, and you have to transport a pallet which is 150 kilo, then you have to select the right AMR and tray to handle the weight.
Yeah, the 250 in this case, to bring the heavy materials. Good.
Then we have, and here we can see actually the fleet manager and the AMR, and that's the communication here. I always use try to visualize it, but let's say the fleet manager controlling the AMR. It's like a taxi company, like Uber or whatever, to keep control of all the taxis, where they are on the map, etc. But it's one thing to know where the AMR are, but it's another thing to understand what's on the AMR. Who are the passengers in the taxi, so to say. Could be the electrodes, X number needed, or a workpiece on a pallet, and where should it go, to which cell, in which order, etc. So the Workshop Manager 5.0 is like the brain keeping everything, but it has nothing to do with the transport itself.
Okay. This is the central brain
Yeah.
managing all these things, like with the taxi example, like the central station staying on the phone and verifying that the AMR is in the right position, bringing the right passenger or electrode in this. In
and
this
the name of the
situation.
passenger.
Yeah, also. We know it very well, and all is tracked also thanks to the ID chip. So all is completely traceable. Also after the job is completely done, the passenger is delivered.
And then we also see here that VSM is as normal in contact with the VMC. The VMC is our developed controller who is handling the communication with our robot in the technology cell, but also have the machine interfacing.
Clear.
And here we support all the brands on the market, of course. And the new thing here is the part where VSM is also have a contact with the Beckhoff IPC, which controls the lifter to move up and down and turn off the light curtains and check with the photo cells that it's actually the AMR moving in and not the person.
So the docking and safety functions are all managed in this integral environment, which is all controlled in the top edge at the top level with the Workshop Manager 5.
Yeah. Then together with the Fleet Manager, you get something what we call the I will turn off the names here. Mobile Planner. And Mobile Planner is actually a map of the factory where you run the AMRs. And the AMR itself can be used to scan the factory, the environment, so you know exactly where things are. And then you can build onto that map areas. Here we can see it, we call it speed zones, the green one here. So here it goes with a lower speed, perhaps, because it's tight and there are objects around it that we need to slow down. Or we can also tell that there are areas that are forbidden to go, etc. But elsewhere in between, it's full speed.
Okay, and this can be managed also day by day. For instance, the forbidden zones can be perhaps set for a certain period because maybe we have a maintenance on that area, so we can temporarily change the map.
Yeah.
But to initialize the system, would it be nice to give as an input a map of the factory, like a DXF file?
Definitely. I mean, that could be the smartest and quickest way if the map is correct completely.
Accurate, yeah.
Of course, you can use a DXF and import it, but you can, if there is, let's say, you forgot to add a pillar in the factory. Of course, the AMR will avoid the pillar. When it comes to the pillar, oh, there's something in the way, we have to go around it.
Okay.
But if you scan with a robot, you make sure that you know the exact position of the pillar, and that means it doesn't have to every time come there. Oh, there's an object which I have to go around. When the pillar is there, it finds a smarter way directly with full speed.
Okay, so then again, let me understand if I got it really. The fact is that if there is an obstacle that was not in the DXF map, anyway, the AMR is able to avoid it.
Yeah.
But we don't want it every time to be surprised about the presence of this. So we make a scanning tour so that this obstacle is added to the map by the AMR. And hopefully it is shared between all the AMRs, because at this point the map is common to all the AMRs running around there.
And we all know that a factory environment is always constantly changing. You are adding a bench or a machine or a chip conveyor or whatever and move it, and then you have to scan again. But that is the work that you can easily and quickly do with the AMR.
Correct.
Okay, if we look on the mobile planner, it's actually not only a map, but you can also see the AMR moving real time
live.
on the map. Yeah,
Beautiful.
And if you have several, you see several AMRs. And here you can see the positions in front of each cell, and also certain goals where we stop and then the AMR have to to move into a certain area and follow like a line or find a way more detailed. And if there's an object, a person, human being coming in the way, you can see on the mobile planner map, it's like a clutter, like a radar that you see a clutter. And then you see how the AMR is recalculating the route and goes around the human being.
Yeah, so that one is the operator, he is there, the AMR is avoiding him, and then it's moving away.
Yeah.
Nice.
I should mention as well a simulation tool that we have invested in called Simio. And the reason we are doing this is that I mean, it's like you said, we are adding a second robot layer on top of it. But all robot cells which are going to be served by an AMR in some way make it rather complex. And if you add several AMRs and you have different cycle times in each technology cell, and you have a mix of cycle times, of course, you have like a worst minimum and a maximum. We need to simulate this so we can see the worst case, the best case, but also see so the AMR will not be overloaded.
Yeah, my brain is already burning trying to figure out how many AMRs I should add due to the needs of the day and the average needs of my factory.
And this is also a very good tool in front of the customer to see, okay, you need to have a second AMR because it will be overloaded. Or many times you're surprised, it's enough with just one AMR.
Well, can be.
Yeah, because you have the small buffer in the technology cells and depending on the cycle time.
Well, so if all is properly dimensioned and the measurements are taken in a proper way, also the input data for the simulation are good, we are almost safe saying that, okay, in this case with 2 AMRs, we are good.
Yeah. Okay, a little bit more marketing tools in that sense. And as we are planning to launch this AMR solution this year, I will speak about it, but we have produced the videos. We have a 2-minute product video that we show on our homepage. And we have also started to communicate on social medias like LinkedIn, so there's a shorter version. We have also spent time and money on an animation tool where we actually built a virtual factory. Simulates to be the lights out factory in that sense, where you have technology cells, material buffer, preparation, parking, and you can visualize this in a good way for customers who are interested in this. And it's not just a movie; it's you have kind of interaction together with this animation, so you can look how it will see when you go to a preparation cell, or when you move material to a buffer, or when you request to have material to a milling cell and then transport it with the AMR and lift it into the. So these are really good tools to show and explain to the market.
So System 3R prepared so many tools from a video to the very interesting animation tool, but where do we find this? All these materials?
We have put all on our webpage, system3r.com.
Easy to find, system3r.com.
So there is brochure material, that's the video, it's the animation, and there are, explaining text and pictures about the AMR and the different versions.
And the new things, and hopefully good testimonials in the evolution and the future of this nice system.
That's the evolution, yes, to find and have customers and get the testimony from them. So, before I start and actually have a look at the animation, I would like to add here that we are launching AMR solution together with the VSM5 supporting the AMR. And System 3R as brand will participate on the AMB exhibition in Stuttgart.
Okay, in Germany.
10th to 14th of September this year. And here we will actually in the booth show the AMR solution live.
Moving.
Yeah.
Right. Beautiful.
Where we can see the lifters, the trays, and how it interacts with the Work Partner One Plus.
Oh, yes.
And we also have a preparation cell in that sense. And so that will be the starting point and the launch for the product. Exactly at the same time, 10th to 14th, we also have the exhibition in Chicago.
Oh, well.
And we intend to do a copy-paste from the AMB also at IMTS. So we will show as well the same thing and launch it there on 2 markets at the same time.
So what are you waiting for? Buy the tickets and go immediately to see our launch in Stuttgart and also in Chicago.
You are very welcome to come and visit us and discuss what your ideas about a lights out factory, and we can help you to provide you the solution that you really want. So I will now start up the demonstration of the animation tool.
Let's play it.
Yeah. Let's show the animation tool, which you can find on the system3r.com website. I have it here integrated, so I will just click here, so we start it up. And the beginning of the sequence is just we fly through the virtual factory that we have built up. We can see a full virtual factory with the AMRs moving around. But here you have to interact. So you can click on the plus signs, and then there is a sequence starting when clicking on it. We can just click shortly here on the VSM5, and this is showing some screens where you have the magazine content, the orders, etc. And this can also be connected to your ERP system, so you can import the orders from there. But let's go to the preparation cell. So we click here. Here we see it, and we also see that we have some screens where we have the Workshop Manager 5. So there we prepare the order, link the NC program, connect the workpiece on the pallet, and read off the ID chip. And same thing with the electrodes. So when that is done, you can either ask for an AMR to come and pick it up and bring it to a technology cell, or you can just also send it to what we call the material buffer cell. In a material buffer cell, of course, then you can put it in directly by a human being. That's much quicker in that sense, because this will be the storage. Okay, let's go directly to a milling of electrodes. So we click on this cell, and here we see a Work Partner One Plus and 2 milling machines. Now the material buffer cell is preparing the electrode material that we requested for, in this case 4 electrodes that will be milled in the milling cell. The tray is left at VPT1 Plus, and the AMR can go and start another job and move stuff. But now the VPT1 Plus robot is filling up the local buffer, and then when it's time to run the jobs, it's lifted into the machine table, into the chuck, and we are start milling. And when finished, it will take the next job, etc., and put it into the local magazine. Here you can go through here. It's the die sinking cell. We have also the milling cell. We have washing. We have CMM. We also have some cockpits of the cell OE. So here you can click on the plus sign, you can stop, you can speak, you can play, and you can go back. Okay, that was a short, you can play a longer time with it, of course, but that gave you some hints on how it works, and you can stop, you can talk, you can play, etc. And in front of a customer. So we will actually have this tool as well on the big widescreen touchscreen at the exhibitions.
Nice.
So we can start and play.
Beautiful.
Okay, questions.
I feel my mobile,
Yeah.
which is connected to the chat,
I
is
assume we
vibrating.
have a chat with some questions alongside here with this presentation. So
Let's see some questions. Akshay, sorry for the pronunciation, is asking, please clarify, how do we calculate the maximum weight you can carry over an AMR? I'd like to know the limit weight, he says, that the AMR can carry in terms of workpiece weight, payload.
of course, I mean, I mentioned that an LD90 can handle 90 kilo on top, but what is the workpiece weight? And also, I mean, we put the pillars with the comb, we put the tray. Of course, we work with aluminium material,
Yeah,
which
as
is
light as
lightweight,
possible. Yeah.
We need to have some positioning of the pallet. On top of the pallet, you can have a vise, which is in steel perhaps, and it has a weight. So, of course, we cannot just say that the workpiece weight can be 250 kilo on an LD250 or 90 kilo on a LD90. You have to make sure that in the end you have all the components needed here. But roughly, if you take the tray, you take the pillars, etc., you could say that 50 kilo, let's say, roughly.
On the small one, 50 kilograms.
Yeah. And also on the bigger one, it could be 200 kilo.
Yeah, roughly.
Removing the parts. But I would say, depending on the weight of the fixtures or vices, it could be heavy. So
it's case by case. So for our friends that are asking this, feel free then to get in touch with our sales support, and we can calculate together with you which will be the highest weight that we can carry on a certain side of AMR, and then if needed pass to the bigger sides, or even to the cart, which can bring even more load. Then another question I see, Daniel is asking, my workshop area is not covered by a strong Wi-Fi connection everywhere. For instance, in the storage area, it says, do you provide a dedicated network? What should I do for having the best connection?
Well, for the best connection, we actually suggest that you have a 5G network, especially for the AMR. We have tried it out in our facilities on the local network that we have, but a dedicated network for the AMR is the best solution.
Okay.
Because then you can also lock a free bandwidth or channel for the AMR to work within, and then you don't have any disturbance.
Right.
But of course, then you have different areas in the factory layout as well.
Yeah.
But the smart thing here is that you can use actually a software option from Omron.
Oh, beautiful.
They call it Flow IQ, and that means we can go with the AMR in the factory, all places where it should move, and then we can, get the signal if it's strong, good enough, or bad. In there could be dark corners or walls that gives
That's on signal limitations.
Signal limitations.
Okay, so we can, like we scan the map, we can also scan the Wi-Fi.
Yeah,
somehow.
correct.
To see
That's
if
a good
the connection is well done. Beautiful then.
Yeah.
And then call your IT guy who will be busy together with us in order to get the perfect connection, I would say. And let's look, we have plenty of questions, but let's find another one, last one before closing this session. Arthur is asking, can I run the AMR outside the factory? The machines are in two different buildings, he says. It's a particular case, he's passionate with rally, maybe.
I mean,
possible?
Of course it can run inside the factory, that's the purpose with it. But we say no, not outside. There could be rain, of course, there could be a slippery floors or obstacles in the way, grains and stuff like that. So no, not outside. It has to be a factory environment where, of course, normally a factory has a concrete floor, perhaps you have a coating on top, and so on. That's perfect. We actually tested to run the AMR on a carpet as well, and it works really fine.
Nice with the carpet.
Of course, there has not to be any steps, but there can be a slope, a certain angle. It works fine as well. We have tried it out. So, but the question outside
on the rain, maybe
it's
not. Not okay. Okay. Anyway, if there is a step or an unforeseen obstacle, even if it is very thin, it can be detected by the lower radar that we mentioned before. So even if maybe there is a too big and too tight carpet, that one we say okay. Let's make a little slope to connect it, or in any case it will stop for safety reasons, also to preserve the integrity of the AMR itself. Nice. We have other questions, but perhaps it would be better then to group them and to give some answers one by one, and perhaps if we have following further questions, yes, we have a contact, right?
Yep. I mean, if you, prior to this webinar, you have questions coming up and popping up, you can always send an email to Hans Mustonen, who is the AMR product manager. You saw him here today.
Yeah, correct.
On the connection to Vällingby, actually. And so we can give a written answer to you. So please, if you have questions, just email Hans.
He will be more than happy to answer from the field. So if you also want to experiment something, it will be the right person and the right place to test novelties that may come also from your requests. True. Because we have open eyes, but your eyes are even more open on the reality on the field and bring us nice cases to further evolve with this product. Okay then.
Yeah, so
we reached the end of this webinar. Thank you, Dick, for being here so available. Thanks to Hans also for showing us the reality in our laboratory and factory in Vällingby. And personally, I thank you all in the audience for listening to us. And I hand over for the last greeting to Dick.
Thank you. No, I hope that you have today kind of got our message concerning how we plan to use AMR. Of course, there will be further developments in the future period as well to handle more weight and using the cart, etc. And also depending on when using cutting tools, etc. Perhaps there will be an AMR with a cobot on top as another step for such things. But we have to come back with that, and that will be a separate webinar just like this to inform you. And but otherwise, we thank you all for participating and listening to us today. Thank you all.
Thank you very much. Bye.
Thank you. Bye bye.